So first question, if t from r to r square defined by t of x equal to 2x comma 3x, show that t is a linear transformation. Here we have to prove that t is closed under vector addition and t is closed under scalar multiplication. So first condition is what? First condition is t of alpha plus beta equal to t of alpha plus t of beta. So second condition, t into c of alpha is equal to c into t of alpha. T from r to r square. So r domain set. So r square co-domain set. So what is domain? So domain means set of all input values. What is co-domain? Set of all transformed values are called as co-domain. So t of x, so domain set to 2x comma 3x co-domain. So t from r to r square. So r set. So domain set contains only one element. So co-domain contains two elements 2x comma 3x. Show that t is a linear transformation. So given t of x equal to 2x comma 3x. So 2x comma 3x belongs to r square. Now let us consider any two elements of a domain set. So alpha is equal to x1 belongs to r. So again beta is equal to x2 belongs to r. So alpha, so t of x, so first element to x1. So second element is what? x2. So x1 is belongs to r, again x2 belongs to r. So alpha is equal to x1 first element, beta equal to x2 second element. So next we have to find t of alpha and t of beta. So t of alpha is equal to, so alpha is equal to what? So alpha is equal to x1. So t of x1, so given t of x equal to 2x comma 3x. So t of x1 is equal to 2x1 comma 3x1 belongs to r square. So 2 elements belongs to r square. So next to, so t of beta, so t of beta is equal to t of x2 is equal to, so t of x equal to 2x comma 3x. So t of x2 is equal to 2x2 comma 3x2 belongs to r square. So next we have to prove that t of alpha plus beta is equal to t of alpha plus t of beta. Alpha and beta be any two elements of a vector space V. Let us consider LHS. So LHS is equal to what? T of alpha plus beta. So t of, so alpha is equal to what? So alpha is equal to x1. So beta is equal to what? Beta is equal to x2. Okay, na? So alpha equal to x1, beta equal to x2. So consider given. So given t of x equal to 2x comma 3x. So t of alpha plus beta is equal to t of x1 plus x2. So alpha equal to x1, beta equal to x2. So given, so t of x equal to 2x comma 3x. So t of, so x equal to what? So x equal to x1 plus x2. Okay na? So t of x equal to 2x comma 3x. So x equal to x1 plus x2. So here 2 of x equal to x1 plus x2. So next to comma 3 of, so x equal to what? Again x1 plus x2. So 2 of x1 plus 2 of x2 comma 3 of x1 plus 3 of x2 belongs to r2 square. So next we have to separate x1 and x2 terms. So 2 of x1 comma 3 of x1. So what is the sign? So sign, so plus, so 2 of x2 comma 3 of x2. So vector addition 2x1 plus 2x2. So comma 3x1 plus 3x2 na. So 2x1 comma 3x1 is equal to what? T of alpha. 2x2 comma 3x2 t of beta. So t of alpha plus beta is equal to t of alpha plus t of alpha plus beta for all alpha beta belongs to V. So t is closed under vector addition. So next we have to prove that t is closed under scalar multiplication. T of c alpha equal to t into c into t of alpha. So consider LHS T into C of alpha. So alpha belongs to V. So C belongs to F. So T of C alpha. So T C. So alpha is equal to what? X1. T into C of X1. So given T of X equal to 2x comma 3x. So T of, so what is X? So X equal to C, X1. So 2 into C of X1. So 3 into C of X1. So belongs to R square. So C is common. So C into 2x1 comma 3x1. So C into 2x comma 3x1 is equal to T of alpha. So T into C of alpha is equal to C into T of alpha. So LHS equal to RHS. For all C belongs to F, alpha belongs to V. So T is closed under scalar multiplication. So two conditions are satisfied, therefore T is a linear transformation.